Hello again, Mrs. Thompson here, and today we will be talking about hydrates. What we're going to do is we're going to take experimental data and determine the formula of that hydrate and then name it. So before we can do that, we need to know what a hydrate is. So here's some vocabulary for you. The first one, hydrate, it's any ionic compound that has water molecules bound to its crystals. Now, not all ionic compounds will form hydrates, but a lot do. And so here I have a picture of what's going on. You have these positive ions and negative ions that make up this crystal, and then within that you have water molecules attached to them. And so they're just kind of bound within the crystal structure itself. What it would look like is something like this. This is copper 2-sulfate pentahydrate. It has copper and sulfate ions, and then it has water in it. And it looks solid. It doesn't look like water is in it at all, but it's actually hydrated. Okay. The way the formula is written is it's written with the compound formula and then a dot and then a certain number to tell you how many water molecules there are. So for example, we have that copper sulfate I was talking about, copper 2-sulfate, a dot, and then 5 H2Os. That means for every one copper sulfate, there are 5 water molecules attached. When you think about the formula, just think about it as it being a plus sign, not times. It's just 1 copper sulfate plus 5 waters. Okay. When we name it, we just take the normal compound's name, and then we add a prefix to tell how many water molecules and the word hydrate at the end. So for this one, that would be copper 2-sulfate. Remember, Roman numerals are there because copper is one of those metals that has more than one charge. Penta, because there are 5 waters, and then hydrate to signify water. Okay, here is just a table of some common hydrates. You don't have to write this down at all. It's just a few showing you what a prefix would be. These are all the normal prefixes we use for naming molecular compounds. Mono, di, tri, tetra, penta, and so on. And then how many water molecules that would mean. 1, 2, 3, 4, 5, just same trend. And then an example formula and an example name. Like I said, you don't have to write this. All right, moving on with more vocab. Another term is water of hydration. That's just how much water is attached to the hydrate. Anhydrate, or sometimes called anhydrous, I will go between both of those. So I wrote both, anhydrate and anhydrous. What this is, it's just what's left over after the water has been removed from the hydrate. And so in this picture here, you have hydrated copper 2-sulfate, that's with the water added, and then in order for it to become anhydrous, you have to add heat. And so it actually changes color from blue to white. And a lot of hydrates do this, but not all. Some of them turn from colorless to white. Okay, I wanted to show you what that would look like. So inside this test tube, you have copper 2-sulfate pentahydrate, and it's being heated by a Bunsen burner. As you can see, it's turned from blue to white because the water was evaporating. And then they went ahead and put water back in to rehydrate it. Okay, so again, as it's heated, it turns from blue to white as the water leaves, and then they show this going the opposite way by adding water, and as soon as it becomes hydrated, it turns blue again. Next, we're going to learn the steps for calculating the formula of a hydrate. Here they are. We're going to use them. So we'll subtract to figure out the mass of water. We'll convert grams to moles. This is very similar to empirical formula. Then we'll figure out the mole ratio by dividing by the smallest number of moles and round to figure out its formula and name it. All right, so I kept those steps right in the upper right-hand corner. And if you want to color code yours, I'm going to color code mine as I answer them. Okay, here's our question. If 11.75 grams of cobalt x H2O. The x is just there to say we don't know that number, and that's what you have to solve for. So just like in math, you're solving for x. It's heated, and 9.25 grams of anhydrous salt remains. Determine the formula and name it. All right, so start with step 1. Subtract to determine the mass of water. And it says hydrate minus anhydrate, which makes sense. You're going to take the thing that has water in it and subtract the thing that doesn't have water in it to get the amount of water. So a hydrate, which is 11.75 grams, minus 9.25 grams gives me 2.50 grams of water. Okay, one thing to notice. I didn't just put 2.5. I put 2.50. Why? So you're thinking significant figures? Yes? Okay, so remember that when you're subtracting, the number of sig figs are determined by the places. And so since both of these have 2 places past the decimal, the 2.50 needs to have 2 places past the decimal. All right. Next, we'll convert our grams to moles, and since that step's in blue, I'm going to do it in blue. It says we'll do this separately, the anhydrate and the water. We're not going to do the hydrate because that's those two together, so we don't really need that information. So we'll take the cobalt chloride, which is 9.25 grams, and to change it into moles, we need to figure out its molar mass. Okay, and we're multiplying by that. All right, so let's see. Molar mass of cobalt 2 chloride. 1 cobalt plus 2 chlorines, looking that up in my periodic table, comes out to be 129.83 grams. That's equal to 1 mole. Okay, grams cancel, and I get 0.0712 moles. That's how much moles of cobalt chloride there are in this sample. All right, and then we have 2.50 grams of water. And so we'll do the same thing, multiply by its molar mass. And so for every 1 mole of water, you'll start to memorize its mass. It's 18.02 grams. That's 2 hydrogens and 1 oxygen added together. And that's equal to a mole of water. Cross out the units and get our moles of water. All right, so that's step 2. We converted the grams into moles. Step 3, determine the mole ratio by dividing by the smallest number of moles. Okay, so if we look at the 2 sets of moles that I have, which one's smaller, 0.0712 or 0.139? It's got to be this one, which makes sense. You're trying to figure out how many waters there are for every one of these cobalt chlorides. So most of the time, or it should, work out to where the water is bigger than the cobalt chloride. Sometimes they'll be just a little bit different because they're 1-to-1, but you really shouldn't end up with the water being a smaller number. All right, so we'll divide both of these by the smallest number of moles, which is 0.0712. Dividing this one, and I'm also dividing the water moles. Okay. Keeping the significant figures, this divided 0.0712 divided by 0.0712 is just 1. And 0.139 divided by 0.0712 is 1.95. I just kept the same number of significant figures to complete step 3. Step 4 is to round it to figure out what the formula is. And so for these, you should end up with pretty close to whole numbers. Okay, so what you're going to do, 1 will round to 1, and 1.95 rounds to 2. So that tells me how many cobalt chlorides and how many waters. So 1 cobalt chloride and 2 waters. Okay, that's its formula. Cobalt chloride plus 2 waters. And we're going to name it. It's cobalt 2 chloride. And how many waters is 2? So the prefix is dihydrate. And so my final answer here is all of this, the formula and its name. So you're going to have to start doing these in terms of a lab. So you'll need to be able to heat some hydrate, drive off the water, measure the masses before and after, and determine the formula of that hydrate. So if you have any questions on these, please make sure that you ask me right away during class time or during practice. Hope one example was enough. If not, you can find more on my website.